Okay, here are our word problems for 5.1 through 5.3. And I'm going to read this. It says, Emily and Delaney are shopping for shoes. Emily buys 3 pairs of flats and 2 pairs of heels for a total cost of $128.95. Delaney buys 2 pairs of flats and 5 pairs of heels for a total cost of $195.93. Find the cost of a pair of flats and the cost of a pair of heels. All right, when you see total costs, two different ones, you need to think of, first of all, you have to add individual parts to equal a total. So um, first identify your variables here. Your variable is always going to be something that's changing in here. And what we're going to do is we're going to use the letters in our equations will represent what the variable is. So it helps us at the end figure out the solution. So we have a question here talks about flats and heels. So I'm going to use, let's say, F for the cost of the flats because they're asking us to find the costs. When you're asked to find something, that's going to be a variable. So F is going to be the cost of the flats. And then I'm going to use H to be the cost of heels. Helps if I can actually spell heels correctly. I put heels as in you're healing somebody of a sickness. All right, so let's see if I can, here we go. All right, so I have two different situations here. The first one is when we have 3 pairs of flats and 2 pairs of heels for a total cost of $128.95. That's going to be my first equation here. So how I would write that would be 3 flats plus 2 heels equals 128.95. Then I see 2 flats and 5 heels for a total cost of 195.93. So that is going to be written as 2f plus 5h equals 195.93. So there is our system of linear equations, and now we need to solve this. So first off, when you have standard form like this, we're going to use elimination. And in this one, notice that I can't turn a 2 into a 3 or a 2 into a 5. And there's no negatives anyway, so I'm going to have to change both equations. So let's go ahead and do that. Um, so my numbers are a little bit smaller. I'm going to multiply to get rid of my f's. So here's the trick. Multiply by the other equation's coefficient. So if I look at this first equation, if I want to get rid of the f's, I'm going to multiply by the 2 from the second equation. For equation number 2, I'm going to multiply by the first equation's coefficient, which is a 3. Now the problem here, because when I do this, 2 times 3 will give me 6. They're both positive. That's my problem. So I need one of them to be negative. So I'm going to go ahead and just make one of these a negative. I just so happen to do the top equation. Now I'm going to rewrite these now with my distributive property and see what we get. So the first equation, when I distribute that -2, I get negative 6f minus 4h equals negative 257.9. The second equation is going to give me a positive 6f, a positive 15h, and then equals 587.79. So now I can go ahead and line these up, and my f's cancel. I'm going to get 11h equals 3289, and then when I divide, I get h equals, and I'm going to put a little money sign here because these are the heels, $29.99. All right, $29.99. That's one of these. It also says we have to find the cost for the flats. So we're going to go back and use an original equation. For me, I'm going to use this equation right here, this equation number 1, and then I'm going to plug in that 29.99 for h. So here we go. I'm going to write 3f. Oops, helps if I write it where you can see it. There we go. 3f plus 2 times 29.99 equals 128.95. So that's going to be 3f plus 59.98 equals 128.95. When I subtract, I get 3f equals 68.97. And then when I divide, I get my flats are equal to, put my unit in here, $22.99. There we go. There's example 1. And now we're going to move on to example 2, which is our last example for the notes today. Denzel has a piggy bank with only nickels and quarters in it. There's a total of 52 coins in the piggy bank for a total of $9.20. How many of each coin is there in the piggy bank? All right, so variables here. I have two things. They're asking us for how many of each coin. So we're going to use n. It's going to represent the number of nickels. And then we also have q for the number of quarters. All right, and then two different equations. Notice we have two different totals. The first one is a total number of coins. So that'll be for equation number 1. Total number of coins. That means if I take the total number of nickels plus the total number of quarters, it equals 52 coins. Then we're going to have a total amount, like value. That's going to be equation 2. So values are the following. You have 0.05 cents times every nickel plus 0.25, which is 25 cents times every quarter, equals $9.20. So that's how you would write it. Now there is a little trick here to make numbers a little bit easier. When you're dealing with the coins, you can get rid of the decimals. So instead of saying 0.05, you can say 5n plus 25q. But for the total, instead of 9.20, you're just going to say 920. And it makes it a little easier not having decimals now. So I can easily do elimination if I multiply this top one by, let's say, -5. If I multiply both by -5, I'm going to get a -5n minus 5q equals -260. So if I keep going with this, I'm going to get 20q equals 660. And when I divide, I get q equals 33 quarters. Now, I'm going to go back to my original equation and do n plus, I'm going to plug in 33 for q equals 52. And when you solve, you're going to get that there's 19 nickels. All right, there you go. And in the next video, we will do examples 3 and 4.